في section 4.7 يتكلم عن ال change of bases. فيعني مثلا أنا لو كان عندي two bases، عندي bases B مثلا is equal B1 و B2، عندي another bases مثلا C is equal C1 و C2. for any x موجودة في ال bases B، any x موجودة في ال bases C، so any x for any x in the bases B, it can be represented as x is equal a1 b1 plus a2 b2. Similarly, for any x, so for any x in the basis C, so x can be represented as, let us say, a2 c1, sorry, c1 plus, or let us say a3, this one is a4 c2. So for any base, for any x inside this base or this base, we can represent it as unique representation as this one or as this one. So for this section, we aim to find the relation between the coordinate vector of x inside the basis B and the coordinate vector of x inside the basis C. So the relation between the coordinate vector of this one and the coordinate vector when we have this one. So we have this relation, which is said that the coordinate vector of x to the basis C is equal P, which is the change of coordinate from B to C, multiplied by the change of coordinate, multiplied by the coordinate vector of x to the basis B, where B, the change of coordinate matrix, is given by is the coordinate vector of B1 to the basis C and the coordinate vector of B2 to the basis C. So this is the relation between the coordinate vector of x to the basis C and the coordinate vector of x to the basis B. Since this one is formed from this one, so it is the columns of the change of coordinate matrix is linearly independent, so that means this one is invertible. And in the case if we want to find the change of coordinate of x to the basis B and we are given this one, we can write this one as, so if we multiply both sides by B inverse, so here B inverse and here we have B inverse, so this will give us P inverse of this one multiplied by x and here we have C. So if you want to find the coordinate vector of x to the basis C, just use this one. If you want to find the change of coordinate vector of x to the basis B, just use this one. Here we have some, maybe we can write something here that if we take the inverse of this one, the inverse of the change of coordinate matrix from B to C, it is equal to change of coordinate from C to B. Also, you may, if you don't have, for example, the change of coordinate of x, the coordinate vector of x or coordinate vector of B, but you want to find what is the coordinate vector, so you don't have a matrix, you can do like this one. So from C1, C2, then do row operation for P1, P2, then you will find what is, here we have identity matrix, which is I2, and then you have here your change of coordinate matrix, which is B from B to C. If you are given one of these coordinate vector, you may use this one. But in the case you have only the vector C1, C2, B1, B2, which is the basis, and you want to find the change of coordinate matrix, you have to use this one. Where this one is the identity matrix, then here you will find what is the change of coordinate matrix from B to C. In exercise 1, let B is B1, B2 and C1, C2 be bases for a vector space V, and suppose B1 is equal 6C1 minus 2C2 and B2 is equal 9C1 minus 4C2. A. Find the change of coordinate matrix from B to C. Then B, find the coordinate vector x to the basis C for x is equal minus 3b1 plus 2b2. Use part A. So for the first part, we need to find the change of coordinate matrix from B to C. So we need to find this matrix, which is equal to the change of the coordinate vector of B1 to the basis C and the coordinate vector of B2 to the basis C, which is, so here the coefficient of B1 is 6C1 minus 2C2, so this is 6 minus 2. Then for B2 to the coefficient of B2 to the basis C, we have 9 minus 4, so here we have 9 minus 4. So this is our change of coordinate matrix from B to C. Now for part B, find the coordinate vector x to the basis C for x is equal minus 3b1 plus 2b2. So from here we know that x, the coordinate vector of x to the base P is given by minus 3 and 2. So now we need to find the coordinate vector of x to the basis C, which is equal the change of coordinate matrix from B to C multiplied by the coordinate vector of x to the basis P. So it is 6 minus 2 multiplied by 9 minus 4 multiplied by minus 3, 2. So this will give us 0 and here minus 2. For number 2, similarly, we have here the basis B1, B2, the basis B, then the basis C is C1, C2, and we have B1 is equal minus C1 plus 4C2, B2 is equal 5C1 minus 3C2. We need to find the change of coordinate matrix from B to C. Then we need to find the coordinate vector of x to the basis C, where x is given by 5B1 plus 3B2. So part A, the change of coordinate matrix is given by the coordinate vector of P1 to the basis C and the coordinate vector of P2 to the basis C, which is equal, so the coefficient of B1 here, the coefficient of this one, so the coordinate vector is minus 1 and 4. For B2 it is 5 minus 3. Now for part B, we need to find the coordinate vector of x to the basis C, and from here we can find the coordinate vector of x to the basis B, which is given by 5 and 3. So now a change of the coordinate vector of x to the basis C is given by the matrix change of coordinate multiplied by x to the basis B. So this one is just minus 1, 4, 5 minus 3 multiplied by the vector 5, 3. So this will give us minus 1 multiplied by 5 plus 5 multiplied by 3. So this is 10, then 4 multiplied by 5 minus 3 multiplied by 3, which is 11. So this one is 10, this one is 11.